Welcome, I'm Dr. Alfarah. In this video, I show you how to find temperature and velocity distribution in this example using COMSOL Multiphysics. In our model, we have two domains. It is a cover domain or solid domain, and this is fluid domain. Our fluid is air. The boundary conditions are inlet, outlet, and insulation. That you see that also we have no slip condition for the cover boundary. For modeling or the analysis, the temperature and velocity distribution are modeled. Let's move on to COMSOL Multiphysics. For us start the model, click on Model Wizard. Click on 2D because we have 2D domain. Okay. We have a two physics, fluid flow and heat transfer. So first click on fluid flow, click on single phase flow, and we have turbulent flow. So click on turbulent flow and select epsilon. Okay, click on it. Now let's move on to heat transfer. Click on heat transfer and fluids. Okay, click on it. Click on study. Because we have a steady state condition, so click on stationary and click on done. First, we need to define the domain of our model. So right click on geometry, click on rectangle, the width is 1 meter and the height is 0.1. Okay, click on build selected and then click on circle. Okay, the radius is 0.02. Now click on build select. So the position here we use 0.5 and also 0.05 to insert the circle inside the center of domain. So click on build select. Here you see that we have a domain and also the cover domain. So now let's move to materials. Right click on materials and click add material in library. Here you see that in the recent material we have also cover and air. So if you don't have the fluid in this section, so let's move on to AC and DC. Click on copper and add to component. Okay. For select the air, let's move on to liquid and gases and click on gases and click on air, add to component. Okay. So this is only copper and the fluid domain here. So air is fluid domain and copper is solid domain. Okay, let's move on to turbulent flow. Right click and select inlet for define the boundary condition. The inlet velocity is 1 meter per second and also we define the outlet boundary. So click on outlet and select this boundary. For the outlet, we have the pressure condition and the pressure at the outlet is 0 and this is a relative pressure. Okay, it's 0. Also here, it's very important because in our solid, we do not have any fluid flow, so deselect the copper domain for the turbulent flow. Okay, now click on wall and you see that we have no slip condition in this boundary, and the boundary of the solid or the copper domain. Okay, now let's move on to its transfer in fluid. Here you see that we have two domains, but we need to define the solid domain. So right click on heat transfer and select the solid domain. So we select the solid domain for the heat transfer in solid. Okay. Now we have two domain here, fluid flow and also we have solid domain. Now right click on heat transfer and select temperature. The inlet temperature is 300 kelvins, okay, and also we select flow condition and outflow. Okay, now we define the heat source. Right click on heat transfer in fluid and click on heat source. We select solid domains. The heat source value is 135. The unit is watt per cubic meters. So we have a difference temperature between the fluid and the solid domain because solid domain is heat source. We need to go to fluid 1, okay, and the velocity field is velocity field. We need to select the velocity field from the turbulent flow or epsilon model SPF. Okay, so we select the velocity because we need velocity distribution for solving the heat transfer or the temperature distribution. Okay, now let's move on to mesh. Click on build select. Here you see that we have the mesh for our model. So let's move on to stationary and click on compute to run the model. The calculation has been complete, so let's move on to our result. This is velocity distribution. You see that the velocity distribution inside section and outside section, also center section, is different because we have solid domain and this solid obstacle the fluid flow. So we have velocity distribution according to this figure. It is temperature distribution because we have heat source into our domain. We have increased edge flow temperature because the solid domain or the copper solid had a heat source. The heat source caused the temperature of air increases. Thank you for watching this video.